The unified modeling language is a very complete and very widely used way of expressing, designing, and modeling solutions in OOP. Now, the class diagram is the one that we really look at. We don't really look at other things such as the use case or the messages or any other part of it. And what it really does is it defines inside a box here. If we zoom in, it defines the name of the class, it defines the variables, the state that it has, and it defines the public methods, so that people can look at it quite easily and see what the interface of your class is. Now, in this case, it also indicates with a minus or a plus whether that method is public or private. It also has the variables and their types and the return type of that method, to be strict about it. Now normally, and I've kind of zoomed out way, it's sufficient just to show classes like this in a kind of first view when you're deciding what the classes are. In this case, a shape, well, a circle extends a shape and a rectangle extends a shape, so they're both shapes, and a square is a more specific type of rectangle where all the sides are equal. So there are two main types of relationship. There's inheritance, which is an is-a, and there's aggregation, which is a has-a. However, we also see this sometimes, dependency. It has no real definite equivalent in code. It just means that one class uses another one. But it's very simple to spot in code where inheritance and aggregation are, and they're shown by the arrow and the diamond. Composition is a kind of strange type of inheritance, which we'll look at in a second. It's not on the IB syllabus, but we're going to look at it quickly anyway. So let's read this UML class diagram. There's a general class called a list, and a list of bidders extends that or inherits from list, so therefore it is a type of list. A list of bidders contains bidders. There's a class called an item, which again is related to a list of bidders, but not specifically explaining how. Item is also related to high bidder, but we look at that. If we look briefly at this little thing which I'm circling here, it says 0 ... That is the cardinality of it. That means that there could be 0 items, between 0 and many items related to one bidder. Look at this example of inheritance. A vehicle, then, which is the superclass, is specialized down or inherited from to make a motor vehicle and a bicycle. And a motor vehicle can also be either a car or a motorbike. This is inheritance, or otherwise known as is-a. A car is a motor vehicle is a vehicle. This next example with employees. A contractor is an employee of a special type, and a manager is also an employee of a special type. Now, any public methods which are in employee will automatically get passed down to both contractor and manager, but they don't need to be specifically mentioned here, because as long as they're public, we know that they're going to exist, they're going to be accessible from contractor and manager. And here's a nice example that everyone understands of animals, which an animal can be a mammal, a bird, or a fish. A mammal can be a wild animal or a farm animal. And in this case, we have a little bit of aggregation there as well, because a farm animal exists within a farm. And you can see here that either 0 or many farm animals can exist within one farm. In other words, a farm animal can only exist in one farm at a time, but you could have many of them, or 0 of them in each farm. So unified modeling language contains lots of diagrams, charts, etc. Class diagram is the only one that we really use, and it's one of the most useful ones for object-oriented programmers. It shows class and behavior as well as visibility, public, protected, or public and private, and the relationships between those objects. A relationship can be inheritance, composition, aggregation, and association. Now, I'm going to touch quickly on the difference between composition and aggregation, although we will look at that a little bit later on. Composition means that it can't exist without the class that contains it. So the example I'm going to give you now is room and building. A building contains many rooms, but if I knock down the building, then the rooms will disappear as well. And a room can't really exist unless it's inside a building. So the concept of room only really makes sense inside the class which contains it, i.e. the building. So therefore that is composition. Whereas an employee is contained inside a company, and the employee or the person can exist outside the company, can leave, he can join another company, etc. So that's aggregation. Finally, polymorphism is also shown in this diagram, because if you inherit from one class to another, the public methods which are in this class are automatically in this class as well. And some of those methods may be overridden. So if they're overridden, they're specifically mentioned here. And if they're not, then they just take the straight normal method which is inherited from the superclass. Finally, a little aside, case tools, computer-aided software engineering tools, can be used to generate code automatically from class diagrams, UML class diagrams. It won't generate all of the code, but it will at least generate the skeletons of all of the methods and all the classes and variables.